Hi, this is Shyamala Gauri, Assistant Professor in CSE Department, Rohini College of Engineering and Technology. Subject code CZS 355, Neural Networks and Deep Learning. Unit 3, Third Generation Neural Network. The topic covered in this presentation is a spiking neural network. Its characteristics and its benefits are explained in this presentation. Spiking neural network. A spiking neural network is a type of artificial neural network that more closely mimics the way biological neurons communicate. Unlike traditional neural networks, which process information in a continuous signals, SNNs operate based on discrete events called spikes or action potentials. SNN characteristics. Number one, spikes as information. In an SNN, neurons communicate by sending spikes, brief bursts of electrical activity. These spikes are not continuous signals but discrete events that occur at specific points in time. When a neuron's membrane potential crosses a certain threshold, it fires a spike and the spike is transmitted to another connected neurons. Second one, time dependent. SNNs incorporate the concept of time in their processing. The precise timing of spikes is important for encoding information, allowing SNNs to potentially capture temporal patterns and dynamics, much like biological brains. This is a key difference compared to traditional neural networks, which process information in a more static manner. Number three, neurons and synapses. Neurons in SNN are modeled more realistically than those in ANNs. They typically have properties such as resting potential, the baseline electrical state of the neuron, threshold, the voltage level a neuron must reach before it spikes, refractory period, a short period after a neuron spikes during which it cannot fire again. Synapses, connection between neurons in SNN also have characteristics like synaptic weights and time delays, influencing how spikes propagate. Fourth one, learning rules. The learning in SNNs can be based on algorithms like spike timing dependent plasticity, which is a biological learning rule. STDP adjusts synaptic weights based on the relative timing of spikes between connected neurons, strengthening connections when one neuron fires just before another and weakening them in the reverse case. This is different from traditional backpropagation used in regular ANNs. Benefits of SNN. Temporal information processing. SNNs excel in tasks involving temporal dynamics such as speech recognition, event-based vision, and time series forecasting due to their ability to encode information in the timing of spikes. Energy efficiency. SNNs are considered more energy efficient because neurons only fire when necessary, unlike traditional neurons in ANNs, which continuously update and process activations. Biologically inspired. Because of their more direct connection to how real neurons operate, SNNs offer more insights into biological neural processing and could eventually be useful in neuromorphic computing, which mimics brain like computation. Challenges. First one, complexity. Training SNNs can be more difficult than training traditional neural networks. Methods like backpropagation are not directly applicable to SNNs, and specialized learning rules like STDP are often used, which can be computationally intensive. Second one, hardware requirements. SNNs require specific hardware designed for spike-based computation, such as neuromorphic chips, although some progress has been made in adapting them to conventional hardware. Thank you.